In this last unit of Tier 1, we're going to be discussing real numbers. So first, let's start off by talking about what are real numbers. So you can see there are different types of numbers. The most basic type of number that you're probably familiar with is going to be whole numbers. Whole numbers are your counting numbers that start with 0. So 0, 1, 2, 3, 4, going on forever. Integers are a next set of real numbers. The difference between whole numbers and integers is that integers include negative numbers. Notice that neither one of these categories includes fractions or decimals. So integers, although they can be negative, they cannot be fractions or decimals. Whole numbers have to be positive numbers. Now the next set that encompasses both integers and whole numbers is going to be rational numbers. So rational numbers can be fractions, they can be decimals, they can also include whole numbers, and they can also include negative numbers as well. But the big distinguishing characteristic is that rational numbers are the only ones that include fractions and decimals. Then you've got this little category that's over here by itself. And these are called irrational numbers. Irrational numbers are kind of like it sounds, kind of like an irrational person. They go on, they repeat forever in form of a decimal without any rhyme or reason. So if you take a minute and you put the square root of 2 in your calculator, there is no pattern, there is no reason, there is no rhyme to that decimal. It just goes on forever. The most famous irrational number is going to be pi. So how do you distinguish between rational and irrational? Rational numbers are fractions and decimals, and the decimals have a pattern to them. So 0.56 repeating, it goes 56, 56, 56, 56, going on forever. Whereas irrational numbers are going to repeat as a decimal, but you're not going to see a pattern with them. All of these classification of numbers are examples of real numbers. We're going to be focusing our efforts on integers. So integers, again, can be positive, and integers can also be negative. If you're thinking about your number line, 0 is what separates your positive and your negative numbers. Positive numbers are to the right of 0, negative numbers are to the left of 0. We're going to be talking about the operations with positive and negative numbers. I am not going to spend too much time on this in this video, as I'm guessing that the majority of you are going to be putting these into your calculator. Again, it kind of breaks my heart, but it's okay. If you're using your TI-30 or your TI-34 calculator, your negative symbol is right next to your equal sign. Please do not use the subtraction key as a negative. Again, the negative is right next to the enter button down there at the bottom right-hand corner. I do want to go over, however, the rules for adding, subtracting, multiplying, and dividing integers, because it is something that's important for you to know. When you get later on into future math classes, I don't really expect you to break out your calculator every time you need to do an operation with a negative number. Now, if numbers have the same sign, so if they're both positive or if they're both negative, you will just add those numbers together and keep the sign. I mean, if you have two positive numbers, we know the answer there, but just to prove that point, a positive 3 and a positive 1 adds to give you a positive 4. So if you add a negative 3 and a negative 1, it's just like money. Think about it that way. It's like I lost $3 and then I lost one more dollar. Well, you're still in the hole. You didn't go positive anything. So negative 3 plus negative 1 is going to give you negative 4. This is where things get tricky with adding. If you're adding and they have different signs, essentially what you're going to do is subtract, and then you're going to take the sign of the larger number. So it's almost like, think about it like money. It's like, which one do I have more of? So if you had positive $3 and then you lost $1, which is a negative 1, it's like, how much do you have? Well, notice you have more positives than you do negative. So we subtract these and we say 2, but my answer is going to be positive 2. Because again, I have more positives than I do negative. You can also use your number line, which is depicted here. Imagine positive is going to the right 3, but then negative means you're going down 1. For my people that like football, you can kind of think about it that way. Now, so just to recap, the sum of two positive numbers is still positive. The sum of two negative numbers is still negative. It just gets tricky when the signs are different. So if I had 8 plus negative 2, I'm going to subtract and say the answer is 6, but notice I have more positives in this case than I do negatives, so my answer is positive. In this one, I've got -8 plus -2. I have more negatives than I do positives, so my answer in this case would be -6. Now, in terms of subtracting integers, as long as you memorize the rules for addition, you don't really have to memorize anything for subtraction other than change the subtraction to an addition sign, and then you change the sign of the number that's behind the subtraction symbol. So 12 minus -6 is the same thing as 12 plus +6. So you may have heard it called keep, change, change. So change it to an addition and change the sign of the number behind it. So 12 minus -6 is the same as 12 plus 6. So my final answer here would be 18. Now, in terms of multiplying and dividing integers, if the signs are the same, the answer is going to be positive. So you can think about this little visual here, the little smiley face's eyeballs are the same. He has positive eyes, that makes him happy. He has both negative eyes, that makes him happy. Both signs the same, you're going to have a positive answer. If you have different signs, so poor thing has little mismatched eyes here, if you're multiplying positives and negatives together, your answer will always be negative. So this is just a summary of the integer rules, so you can print this out for your reference. Let's take a look at some examples. -5 plus 7, the signs are different. Now I always want to subtract, so my answer in this case is going to be 2. I have more positives than I do negatives, so it's going to be a positive 2. Both of these are negatives. Again, I'm adding, so a -21 plus a -15 is going to be a -36. Signs are different in this case, so I'm going to subtract 18 minus 7, which is going to give you 11. I have more positives than I do negatives, so it's going to be -11. If it's subtraction, change it to addition, and then change the sign of the number behind it. So -13 plus -6 gives me -19. Again, keep the first number, change it to addition, and change the sign of the number behind it. So 34 plus 9 is going to give me 43. Multiplication, if the signs are different, you're still going to multiply, but if the signs are different, your answer is going to be negative. If the signs are the same, so even if they're both negative, I'm going to have a positive answer. Different signs means negative answer. Different signs with dividing means negative answer. Same sign with dividing means positive answer, so +9 in this case. Let's talk about absolute value. So absolute value means the distance a number is from 0 on the number line. No matter if you walk forwards or if you walk backwards, distance is always positive. Absolute value you're going to see denoted with bars around a number. Do not get that confused with parentheses. Parentheses does not change the value of a number, but if you see a number in bars, I could say +5 or I can say -5. But if there are bars around that number, both of these have a final answer of +5. Let's talk about, as our last topic, order of operations with negative numbers. Order of operations still applies. Please excuse my dear Aunt Sally. Remember, like we talked about in the very first video, multiplication and division go together, and addition and subtraction go together. So in this problem, you have brackets, and then you have parentheses inside the brackets. So this right here is going to be my starting point. 2 times -6 is going to give me -12. So this is going to become 3 plus -12. Now that's still inside those brackets. I did not drop them because I'm not through with them. Now 3 plus -12 is going to give us a -9. So this is going to become 5 minus -9. So I'm done with that step. Remember, when you're subtracting, minus is the same thing as plus, in this case a +9. So I change it to addition and then change the sign here. 5 plus 9 is going to give me 14 as my final answer. In this problem down here, I'm going to start with the parentheses. So 12 minus 6 is going to give me 6. Keep in mind, we talked about in the first video what this means. This means 6 times 6. That 6 is being multiplied by my answer here. So this is 9 minus 36. Remember, 9 minus 36 is the same thing as 9 plus -36. So if we do 9 plus negative 36, I'm going to get a negative 27. This is where you want to be careful. We have bars around here. Bars are like the same thing as parentheses. They are a grouping symbol, but regardless of the answer we get inside these bars, remember what the bars are going to tell us to do. It's going to change that number to a positive. Bars always mean positive. So let's start inside these bars here, and we're going to do 8 minus 2. So this is going to be 6 plus 4, still inside the bars. 6 plus 4 is going to give me 10 inside my absolute value bars. Now, does that change the value of 10? It never changes it to a negative. It's going to stay positive. So really, this means 6 times 10, which is going to give me 60. I want you to pause the video and try one on your own, and when you're ready, hit play to check your answer. Now, in this first one, we see these grouping symbols, which are these bars. I'm going to start with the multiplication. So this is going to be 3 times 3, which is going to give me 9. I'm not done with those bars. I'm going to do 8 minus 9, which is going to give me negative 1. So what do these bars mean? This means this is going to change to a positive 1. So what this means is 7 times positive 1. So 7 times 1 is going to give me 7. And then 4 plus 7 is going to give me a final answer of 11. Now, if you have a fraction with order of operations, you always want to do the numerator and the denominator separately. So in my numerator, I have brackets, not bars, brackets. So what this means in my numerator is 3 times 4 minus 5, which is going to be, 4 minus 5, which is negative 1. 3 times negative 1 is going to give me negative 3. And then 9 plus negative 3 is going to give me a positive 6. Now let's do my denominator. It's almost like two separate problems here. I'm going to start with my grouping symbol, which in this case is my absolute value bars. That's going to change this to 3 squared minus positive 6. Now 3 squared is going to give me 3 times 3, which is 9. And 9 minus 6 is going to give me 3. So what do I do with these two answers here? Keep in mind, fraction bars are like the same thing as division. This is 6 divided by 3, which is going to give me a final answer of 2. There is one more concept I want to talk about in terms of real numbers, and that is going to be evaluating expressions. So sometimes in math, we use a variable or a letter to represent an unknown number. Now, if you are given the value of that variable, what you're going to do is plug it into your expression and then evaluate it. Now, if you see a number and a variable, like in this first one, written side by side means to multiply. This does not mean 25. What this means when I go to plug this 5 in for x, this means 2 times 5 minus 3. So when I plug in 5 for x and do 2 minus 5, still follow your order of operations, this would be 10 minus 3, and so we're going to get a final answer here of 7. Let's look at another example. Again, I'm going to take these two and I'm going to plug them in every time I see x, and then I'm going to plug in 2 every time I see y. So this means 15 plus 3 times x, which is negative 7, and then minus 2. Order of operation tells me I need to do that multiplication first. So this is 15 plus negative 21 minus 2. I'm going to do my addition next. 15 plus negative 21 is going to give me a negative 6. And then negative 6 minus 2, keep in mind that's add the opposite here. So that's the same thing as negative 8. Pause the video and try these on your own, and when you're ready, hit play to check your answer. In this first one, I'm going to do 5 times 5 minus 3 times 1. So this is going to be 25 minus 3, which is going to give me a final answer of 22. And this one means 5 minus 2 times negative 2. So we're going to do our multiplication, which is going to be negative 4. And then 5 minus negative 4, we're going to add the opposite, which is going to give me a positive 9.